Okay, so for the first time in more than 50 years, we're in a full-blown race back to the moon. But you know what? This isn't your grandfather's space race. We're not just talking about planting flags and snapping a few photos. Nope. This time, the mission is way bigger, way more ambitious, and it's all focused on one specific part of the moon we've never even touched.
Yeah, you heard that right. The whole game has changed. This isn't about visiting anymore. It's about building a permanent, sustainable human presence off-world. We're talking about a real lunar base, a place where people can live and work.
So you gotta be asking, what happened? What changed? After decades of, let's be honest, kind of ignoring the moon, why is every major space power and even private companies all of a sudden scrambling to get to one specific spot? We're talking about the lunar South Pole, a place of eternal darkness and unbelievable cold. Well, the answer lies in a hidden resource, one that could literally unlock the rest of the solar system for us.
All right, let's dive in. Think of this whole thing as a modern-day gold rush. But the treasure everyone's after, it's not gold. It's something way, way more valuable for the future of humanity in space.
So what is this incredible prize?
It's water.
Yep, simple H2O in the form of ice. It's been tucked away for billions of years in these super dark, super cold craters at the moon's south pole. And believe me, this isn't just any old ice. It's like a frozen time capsule of the early solar system. The reason this ice can even exist is because of these incredible places called permanently shadowed regions, or PSRs for short. Just imagine craters so deep that sunlight has never hit the bottom. Ever. They are some of the coldest spots in the entire solar system, acting like perfect cosmic freezers. For billions of years, they've been trapping and preserving ice from comets and asteroids. Now, this is what makes the lunar South Pole so ridiculously perfect. It's this amazing contrast. On the one hand, you've got the rims of these craters, which are called peaks of eternal light, because they're bathed in near-constant sunlight. Perfect for solar panels, right? And then, literally right next door, you have the craters of eternal darkness, holding all that frozen water. It's like finding a gold mine right next to a power plant. This is easily the most valuable real estate off-world. Okay, so we found the ice. Awesome. But so what? How does a bunch of frozen water on the moon completely change the game for space travel? Well, the magic happens when you turn that raw ice into something much, much more useful. The whole idea is based on this concept called In-Situ Resource Utilization, or ISRU. It's a fancy term for a simple idea: living off the land. Instead of dragging everything you could possibly need from Earth, which is insanely expensive, you just use what's already there. And on the moon, that #1 local resource is water ice. So how do you actually turn ice into rocket fuel? Well, it sounds like science fiction, but the process is pretty straightforward, really. It boils down to 4 main steps. First, you get some robots to scoop up the icy moon dirt, the regolith. Then, you heat that stuff up in a big oven to capture the water vapor. Third, you purify that water. And then comes the magic trick. You split the water molecule apart. And that final step has a name: electrolysis. You basically just run an electric current through the water, and it splits the H2O into its 2 parts, hydrogen and oxygen. The hydrogen is an amazing, powerful rocket fuel. And the oxygen? Well, you need that to burn the fuel. Oh, and it's also kind of useful for, breathing, so you get 2 for 1. Now, this isn't just a bunch of ideas on a whiteboard. We're actively getting ready to do this. I want you to meet VIPER. It's a rover, and its name stands for Volatiles Investigating Polar Exploration Rover. Think of it like a robotic prospector. NASA is sending it to the South Pole to be our scout, to figure out exactly where the best ice deposits are, how much is there, and if we can actually get to it. So VIPER's whole job is to be a treasure hunter. It needs to map out where the ice is and figure out what form it's in. Is it like a solid block or mixed in with the dirt? It's even got a drill that can go about 1 meter deep. Ultimately, VIPER is going to give us the data we need to answer the billion-dollar question: is mining this stuff actually going to be worth it? Right, so whenever you find a hugely valuable resource, what happens next? Competition. And you can bet that this scientific mission is very quickly turning into a high-stakes game of geopolitics. But this time, it's being played on the moon. Let's be crystal clear. This is not just about science anymore. This is a strategic competition for resources. Whoever gets there first and figures out how to mine this water effectively, they're going to have a massive advantage. Controlling the water means controlling operations on the moon, and that translates directly to power on this new frontier. And you can already see the battle lines being drawn. Two big teams are forming. On one side, you have the Artemis Accords, led by the US. Their whole philosophy is about commercial space, letting private companies take the lead, kind of like the Wild West. Then you've got the other team, the ILRS, led by China and Russia. They're going for a more traditional government-led approach. These are two completely different visions for what our future on the moon should look like, and they're on a collision course. So how is this even allowed? Well, it all comes down to a loophole in the original rulebook for space, the Outer Space Treaty from 1967. It said pretty clearly that no country could own the moon. But it was kind of fuzzy about what companies could do. And that little bit of ambiguity, it's the crack in the dam that's unleashing this whole new scramble for the stars.
Okay, so let's zoom out. What's the end game here? Why does a patch of frozen dust at the lunar South Pole matter so much? What's the grand vision for all of this? The ultimate goal, the big prize, is to turn the moon into a gas station in space. See, the hardest and most expensive part of any space mission is just getting off of Earth, fighting our massive gravity. If you can make rocket fuel on the moon, where gravity is way weaker, rockets can launch from Earth with less fuel, top off at the moon, and then head out to places like Mars. It's a total game changer.
So, let's wrap this up. What are the big takeaways? First, making rocket fuel on the moon could crash the cost of space exploration, opening up the entire solar system. The moon is no longer just a destination. It becomes the critical stepping stone to Mars and beyond. And some people are dreaming even bigger, imagining moving huge energy-sucking industries like data centers completely off-planet, powered by the moon's constant sunlight. Which brings us to a final, pretty heavy question. This new moon rush offers this incredible, almost unbelievable future for humanity. But as we take our technology and our ambitions out to these new worlds, are we also just taking our old problems with us? Our rivalries, our fights over resources? As we finally reach for the stars, the real question is, can we do better this time? Can we actually manage this new frontier more wisely than we've managed our own world?